Okay, quick review of the composition of two functions. Suppose we're looking at two functions, f of x, which we'll define as ln of x plus 1. Understand here that we're only taking the natural log of x and we're adding 1. And then g of x is defined as the sine of 2x. Suppose we wish to find f of g of x. So we can write it using parentheses like this, and sometimes you'll see it written with a little open circle. Either way you look at it, you're always going to work from right to left. So in this case, we're taking the g function and we're going to plug it into the f function. So we're going to do this wherever we see an x. So we're taking this g equation, which is the sine of 2x, and we're going to plug that into f where we see an x. So this is going to end up being the natural log of quantity sine of 2x. I'm going to close my parenthesis, and then I have plus 1. So that would be my answer for that. Let's move on to inverse. So the inverse of a function, we use f raised to the negative 1 as our symbol. So if we're looking to find the equation for an inverse, you're simply going to switch x and y and then always look to solve for y. Graphically, a function and its inverse, they are going to always be reflections over the line y equals x. Let's look at a quick example. Alright, so suppose we have f of x equals e raised to the x plus 1, and we're looking to find the equation for the inverse. So we need to switch x and y. Well, first of all, recall that f of x is really y. So if we now switch x with y, we now need to solve for y. Well, y right now is up there where the power is. So in order to bring it down, in order to get rid of everything around it, notice we have a base of e. And recall that e's best friend is the natural log. So we need to take the natural log of each side. So if we do that, we have the natural log of x equals the natural log of e to the y plus 1. From there, the natural log of x equals, these are going to cancel, the y plus 1 will drop down. From there, natural log of x, I'm going to have to subtract over 1. I now have my y alone, and that is the same, or it can be replaced with f inverse, and sometimes we write it with an x. Okay. Keep in mind here that we're only taking the log of x, and if we were to think about the domain of this, x would have to be greater than 0. It cannot equal 0 because we cannot log 0 or a negative number, so this is just kind of an FYI. Our answer to the problem would just be the natural log of x minus 1 if we were asked to find the inverse equation, but a lot of times you will see that domain piece added, just specifying where it's defined. Let's take a look at the graph of our original function f of x and our inverse. So if we were to graph our function e raised to the x plus 1, it would actually go through the point 0, comma e. If I plug a 0 in for x, you're just left with e to the first, which is just e. Remember, e is about 2.7. Now if 0, comma e is on f, e, comma 0 is on f inverse. And you can see here that they are reflections over this line y equals x. Notice too that with f, it levels off here on the x-axis. There is a horizontal asymptote there, and with f inverse, the horizontal asymptote becomes a vertical asymptote. You can see it's approaching the y-axis but never hitting it. Okay, one final note here. If you take a function and its inverse equation and do the composition either direction, what you're going to see is that the result is always going to be x. So if you put f inverse into f or f into f inverse, the result will always be x. That is a useful way for confirming or checking that your F inverse equation is correct.